Okay, let's have a look then. So today we are looking at introducing polar coordinates. So what we do with a polar coordinate, we can define a point in space by defining two values. We start with defining the angle of rotation in standard position of the terminal ray here using theta. And then we define a vector in this direction, which is a movement away from the origin in the direction of theta. We call this the modulus, or r. We call theta the argument. So we can define any point in space in the coordinate plane with an angle of rotation and then a vector direction. So we define a polar coordinate as r comma theta. Let's have a look at some examples. So if we wish to plot some points, this first one here is at 2 comma pi over 3. So pi over 3 is the direction in this direction here. And then we want to move 2 out, so we move 2 there. So this would give us point A is going to be at that point. So 3 pi over 2, we're going to rotate round all the way around to here. And this would give us a rotation of 3 pi over 2. And then we move 1 down, and this gives us point B. 4 pi over 3, well, we might need to divide our space up. This is 1 pi, this is 1 pi over 3. This one here is going to be 2 pi over 3. This is going to be 3 pi over 3. So this one there is 4 pi over 3. That one over here is 5 pi over 3. And the last one down here would be 6 pi over 3. So if we're going 4 pi over 3 and we're moving 3 out in that direction, it's going to bring us to the edge here. And this is point C. We can rotate negatively as well. So a rotation to this point here is pi over 6. So coming back in this direction, this one is going to be 11 pi over 6 or minus pi over 6. And then we need to move 2 out. So moving 2 out from the center in the direction of minus pi over 6 is going to bring us to D. So let's plot and label these points here. So pi over 4, this is moving in this direction here. We need to move 2 out, so we get point A is going to be here. Now, if we do minus 7 pi over 4, so this is 1, 2, 3, 4, 5, 6, 7 pi over 4, minus 7 pi over 4 is in the same direction. So point B is also going to be the same as point A. So we can see two different representations of this particular point there. Let's try C. So for C, we're going 9. So we go 1, so let me change pen. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're back here again. So C is also going to be in the same place. And then lastly, D, we need to move 5 pi over 4. So 1, 2, 3, 4, 5 pi over 4 is this direction. But the vector is negative. So 5 pi over 4 is in this direction, like this. But we're moving backwards. So what we see here in this example is 4 different representations of the same coordinate. And obviously there's an infinite number of possibilities we can play with this one, with forward or negative rotations, complete circles, and then moving backwards instead of forwards. Okay, have a go at this example. So plot the coordinate given and then write 2 other examples for this point. I'll give you 2 minutes for this one. Okay, so let's just resume this. So we need to plot this point. Five pi over 6 is going to be in this direction. This is 5 pi over 6 there. and we need to come out by 3, so we come right out to the outer edge, and that is going to give us our necessary point. So we can do a couple of other things. This point here is minus pi over 6, or it is 11 pi over 6. So we could use either of these two. We could say minus 3, comma, minus pi over 6. Minus 3, comma, 11 pi over 6. And there's obviously a few more examples we can have. We can add another 12 and do 3, comma, 17 pi over 6, and so on. So we can come to this particular point in a few different ways. So we have the coordinate system, and we can define any point in space either using a rectangular coordinate or a polar coordinate. So if we have a rectangular coordinate like this one in terms of x and y, and we needed to find out what r is and what theta is, what would the formula be for that one? Discuss with the person next to you. If we know what the rectangular coordinates x and y are, how could we calculate what the r is going to be, the modulus, and what the argument theta is going to be? Discuss with the people next to you. Okay, so let's hear a few. How do we find out what r is if we have the rectangular coordinates? Ready? Pythagoras' theorem, and if we rearrange it, what would r equal? We don't have a c.
Sorry.
And if we want it to be r equals? We would square root it, like this. And what about theta? How would we find out what theta is? Zahan? Arctan, you mean? Of y over x. So those are the two formulas for converting from rectangular form to polar form. What happens if we want to go the other way? What happens if we want to convert from polar form to rectangular form? What would the formula be? Discuss with the person next to you. Okay, let's hear some answers. Let's have a different table. Yep. Yep. And why? R sine theta. Those are quite easy, aren't they? Okay, so have a go at converting the following points from polar into rectangular. We can have 3 minutes for this thing. So we need to do these conversions, and we have to convert the following points from polar into rectangular. So x is going to be 2 cos pi, and y is going to be 2 sine pi. That is going to give, so the cosine of pi is, top of my head, -1. So this is -2. And the sine of pi is going to be 0. Now, It's actually quicker to do this one, instead of using the formulas, to do this one graphically. If you think about the unit circle, this was a lot easier than you needed to. Ooh. So a rotation of pi is going to put the point here at -2. A rotation of pi in this direction. So obviously this is the coordinate -2, 0, which is what we have there. This one here needs the formulas a little bit more. So we are going to have, we can write it like this. The coordinate is going to be 4 bracket cosine 5 pi over 3, comma, sine 5 pi over 3. So using the exact value table now, we can say that 5 pi over 3 is going to be symmetrical with which particular point? It's going to be symmetrical with pi over 3. So pi over 3 is here. 5 pi over 3 is going to be this one down here. So it's going to have the same cosine value as pi over 3, which is at the cosine value of pi over 3 is a half, comma, √3 over 2. So this one is going to be a half, comma, minus √3 over 2. So we get 4 bracket a half, comma, minus √3 over 2. If we expand that bracket, we are going to get 2, comma, minus 2 √3. Our last one. So this time we want -3 bracket the cosine of 7 pi over 6, comma, sine 7 pi over 6. So that's going to give us -3 bracket. So 7 pi over 6 is going, what's the cosine of 7 pi over 6? That's going to be minus √3 over 2, is that right? And then minus a half. Expanding the brackets, we are going to get 3 √3 over 2. Sorry. Yes. Comma 3 over 2. Okay. Have a go at converting these from rectangular coordinates to polar coordinates. All right, so let's do this first one here. We need to convert this one into polar coordinates. Let's start off by finding our r. R is equal to the square root of -2 squared plus 2 squared, which is going to give √8, which is 2 √2. Theta is going to be arctan of 2 divided by -2. So this is the arctan of -1, which is minus pi over 4. Now, we have to take care with this conversion. Watch this bit carefully. So the arctan of -1 is minus pi over 4, but we need to take care. So sketch a coordinate axis and plot your rectangular coordinate. Your rectangular coordinate is at -2, 2. That's there. Whereas our polar coordinate at the moment is in this direction here. So the typical thing that we would do is we would rotate this angle round by pi. You could make the modulus negative and go in the opposite direction. But I think it's more preferable to have it as 2 √2, comma, and then we add pi to this, which will bring us to 3 pi over 4. There for that one. So let's try our second one here. So we find our R value, do it a little bit quicker this time. That's going to be 1 plus 3, which gives us root 4, which is 2. And our angle of rotation is going to be arctan of negative root 3 over 1. So this is the arctan of negative root 3. That's going to give us an angle of minus pi over 3. Now let's plot the point. We've got 1 across and minus 3 down. So this is in the right location. This is in the fourth quadrant. That's going to be there. So we can give our answer then as 2, 5 pi over 4. Our last one, we can do this one a lot quicker. Notice one of them is 0. So just start by sketching your coordinate axes. We are at 0 across and minus 5 down. So we're straight down here. This is 0, minus 5. Can probably go straight into that one, that this is going to be 5. And then we need an angle of 3 pi over 2. And we can go straight there with that one. Yeah, so with tangent, you have to know that when it's not defined, it's going to be pi over 2 plus n pi. Okay, so this then connects us to complex numbers. So in the Cartesian coordinates, we can plot a complex number, 3 plus 2i, as 3, 2, which means we can also represent this using polar coordinates. So if we have a complex number, typically we use the variable z for a complex number. So the complex number z can be written as a plus bi. It can also be written as r cosine theta plus I sine theta. So complex numbers can be converted into rectangular form or polar form. So if we have a complex number, we can convert these using this formula. So let's do this example. A complex number is represented in the complex number plane with the rectangular coordinates minus 2, minus 2. So plot it so we don't mess up with our argument. So we want it to be down here at, this is minus 2, minus 2i, if this is the real axis and the imaginary axis. So we need to make this into polar form. So firstly, we need to find what our modulus is. So r is equal to the square root of minus 2 squared plus minus 2 squared. Don't take the I. It's going to be a squared plus b squared, not bi squared. So don't bring the I across, you'll mess things up. That's going to give us the square root of 4 plus 4, which is our friend root a, or 2 root 2. And you can see easily if the coordinates have the same number, if they're both 2s, that's one of these multiples of 4, of pi over 4. That's when tangent is always, that's when all of them have the same sort of cosine and sine value. So pi over 4. So we need to, instead of going in pi over 4, we're going to have to rotate it round to 5 pi over 4. So this one is going to be 5 pi over 4. So this gives us the complex number then, what we started off, we have to write it in polar coordinates. This is going to be 2 root 2, 5 pi over 4. So I'm just checking the question. So we can say that minus 2 minus 2I is equal to 2 root 2 bracket the cosine of 5 pi over 4 plus I sine 5 pi over 4. Have a go at this one. 2 minutes for this. Yep. Okay, so a complex number is represented by the point in the complex number plane. Using the polar coordinates, the number can be represented as 4 cis 7 pi over 6. Express the complex number using its rectangular coordinates. So we need to find the x value for this one. So what we've got is we have our complex number is equal to 4 cosine 7 pi over 6 plus I sine 7 pi over 6. So just to help us not make mistakes, plot your coordinate axes. 7 pi over 6 is this one down here, isn't it? That's 7 pi over 6. So this is going to be symmetrical with this point here at pi over 6, which is root 3 over 2 comma a half. So reflecting that one down is going to give us 4 bracket negative root 3 over 2 plus I times a half. Expanding is going to give us minus 2 root 3 minus 2I. And in the question, it's asking us to express rectangular coordinates. So let's turn that now into a coordinate. It's going to give us minus 2 root 3 comma minus 2. Just as a little correction from earlier, I wrote this question here as a 3 there, but I made a mistake here, and this should be 3, not 4. I wrote 4 when I wrote that one down. Okay. So, last question, exam style question. 3 minutes for this one. Let's have a look at this exam style question now. So we have the point P, which we can see here, and we're told that the point P is rotated 90 degrees or pi over 2 clockwise. Now remember, this is the direction of clockwise. Clockwise is a negative angle. In American English, the opposite direction is called counterclockwise. Counterclockwise in the opposite direction. So we need to rotate clockwise by 90 degrees. So we need to make a little 90-degree angle here. And we can see that that's going to bring us here like this. There's a 90-degree angle. So our point K is going to be there. There is K. We need to find out what are we in polar coordinates? Imagine, what are the rectangular coordinates? So we can read off the polar coordinates. This is 2 comma 2 pi over 3. Oh, yes, I see. The scale is different. If we look at the scale there, that's a 4. So converting this into rectangular coordinates now, we get 4 bracket cosine 2 pi over 3 comma sine 2 pi over 3. So this is going to give us 4 bracket. So that's going to give us minus a half, and this one is root 3 over 2. Expanding gives us minus 2 comma 2 root 3 as our rectangular chords. Do we have one that matches that? Yeah, I think A. Okay, that is it for today's lecture.